Coastal geography is the study of the dynamic interface between the ocean and the land. It incorporates both the physical geography and the human geography of coast regions. It also involves an understanding of several aspects, including coastal weathering processes, particularly wave action, sediment movement, and weather. In coastal geography, emphasis is also given to the way in which humans interact with the coast. Coastal areas contain much needed water resources. Hence, they are considered to be the promising places for agriculture, mariculture, and mangrove forests. Time immemorial, beaches are considered to be the best place for picnic, recreation, sporting, social, political, and community interactions. Historically, people preferred the coastal zones for tourism, fishing, mariculture, and water transport. Sunbath and souvenir collection are the regular activities of tourists along the beaches. These are unique and typical land masses bordered by the sea and oceans. Continental shelves and near shore waters comprise only about 5% of the area of the world. In spite of this, 2/3 of the world's population thrives near the coast. The reason is that the coastal zones are the pleasant environments for the human beings. Coasts are not static but dynamic environments involving mass and energy transformations of waves and currents. Shorelines are subjected to both continental and oceanic processes. The life and the environment of these ecosystems are controlled by various abiotic and biotic factors of both land and the sea. Any interfering activity of the land or sea will affect one another and their habitat. The most serious coastal hazards are the attack by cyclone, impact of tidal floods, the killer wave tsunami, and the coastal erosion. In this episode, we are going to study coastal erosion and its environmental impacts. The modules covered in this episode are geomorphology of coast, coastal zone hydrodynamics, causes of coastal erosion, environmental impacts, methods of controlling the coastal erosion. Every continent or island is bordered by the long and short coastline. A balanced climate, pleasant environment, and the availability of rich seafood have made many people to settle along the coastal areas. Coastal line is the line separating the land and sea. Coastal zones are the transition zones between terrestrial and marine habitat. They form an interface between land and oceanic natural processes. Coastal areas also are varied in their topography, climate, and vegetation. Some are sandy beaches, rocky shores, with or without tidal inlets. The climate of a coast are controlled by the land and sea breezes, and the humidity controlled by marine water. Waves are powerful tools for constructive and destructive activities. Hence, the geomorphology of beach materials and processes are always not constant due to the impact of everlasting action of tides, waves, and currents. A typical coastal zone or shoreline is classified into three major parts as near shore, foreshore, and backshore. Near shore is the zone of high wave action, long shore bars, and troughs. Foreshore are seaward dipping and relatively steep zones. Backshore are nearly horizontal flats encompassing the beach face and berm. A beach is defined as a body of cohesionless sediment along a coast that is subjected to the effect of breaking waves. The beach and nearshore meet at the low tide line. The other characteristic features and zones of shore are breaker zone, that is, the area where the incoming waves become unstable, rising to a peak and breaking down. Next type is surf zone, where the waves of translation occur after the waves break. Long shore currents occur in this zone which run parallel to the coastal line. It is called as surf zone. Swash zone. This is the place where the waves backwash the materials. It is the place where up and down movement of beach materials take place. Berms are the flat backshore area on beaches. This is the sunbathing zone with wave deposited sediments. The beach face is the sloping portion of the beach below the berm. This area is partly exposed by the backwash of waves, that means swash zone. A beach is characterized by its geometric profile and the sediments comprising it. The parameters of a beach are its profile, the beach face slope, volume of sediments lying in beaches and their characteristics. Beaches are classified into high, low and moderate energy beaches based on these characters. Normally, high energy conditions prevail during summer months. The wave height increases after the onset of monsoon and produce significant charges in the beach morphology. Before breaking near the shores, waves undergo three major processes. They are refraction, shoaling and frictional attention. Waves impinging on the shore generate typical current as onshore currents, offshore currents or alongshore currents which transport sediments. The geomorphology structures of the shores include beaches, sea cliffs, barrier islands, split and bars, coastal plains and lagoons. Coastal zones are under the continuous action of tides, waves and currents which can erode, transport and deposit the sediments on the shore or off the shores. Winds are the principal cause of waves on the sea surface. The surface gravity waves are an important factor in making the oceans the most dynamic system on the earth. Hence, it is necessary to understand the dynamics of waves. Ocean waves exert enormous energy. They exert a tremendous force on beaches and man-made structures. They are also the potential source of turbine electric power. The surface layers of the oceans are in continuous oscillation due to the presence of waves based on their periodicity. Waves are classified as short period capillary waves, long period astronomical tides and planetary waves. Sea waves are the gravity waves which last within a span of 10 to 15 seconds in the generating zone and 10 to 20 seconds outside the generating zone. The intensity of the sea wave is measured based on its height and length. Both the wave height and length are controlled by wind speed, its duration and fetch or area of water over which it blows. The maximum height of sea waves may be few meters to a few tens of meters. In some places, they may go up to a height of 40 meters. Gravity waves can stress on marine structures and cause extensive displacement of sediments. Waves are capable of displacing their energy from one place to other. Tides are caused by the gravitational forces of the moon, sun, and other celestial bodies. They are also affected by the shape and dimensions of the coastal line and sea floor. Coastal processes such as erosion and accretion are site specific, season specific, and interannual. Different beaches have different geomorphic characteristics and are subject to different oceanographic conditions. Beach processes can vary dramatically from one end of a particular beach to other. Site-specific factors such as extent and health of coral reefs, alteration to dune systems, sediment runoff from upland areas, and other human activities also affect coastal processes. Wave and current patterns change dramatically from season to season and from swell to swell. Because of these variations, each segment of each beach will have its own history of erosion and accretion trends. Coastal erosion is a natural process which can remove, relocate, and rebuild the beach forms. It can also affect the developmental work of human beings like culture, ponds, and boat yards along the coast. The normal processes of a coast are also disturbed due to any change induced by either natural or man-made activity. Some of the notable man-made developmental activities are exploration for heavy minerals, beach placers, marine plants, shells, and fisheries. Activities relating to ports and harbors, settlements, construction of building and shore protection works, recreation, boating, water skiing, and scuba diving, navigation and military camps. The developmental activities also includes intensive aquaculture. Currents are powerful cutting and scouring agents. These are further aided by the rubbing of pebbles as they are dragged along by the moving water. Wave-cut terraces and wave-built terraces are the destructional and constructional landforms developed due to these actions. In general, the rate of erosion is 1 to 2 meter per year over poorly consolidated rock shores. The factors involved in coastal erosions are winter storms. Winter storms tend to sweep beach sediments during winter and are slowly restored during summer. Another factor involved in coastal erosion is backwash. This carries the grains straight down the slope of the beach so that they suffer a net lateral displacement along the shore. Third factor is tidal flow. Tidal flow is the flow of water along the shelf. This also produces movement sediment in the shallow seas of the continental shelves. In narrow straits, tidal flow may go up to 10 km per hour. Fourth factor is change in the sea level. Any change in sea levels may also cause erosion. The fifth factor is reduction of sediment input from rivers will invite sea erosion. The next factor is geomorphic setting, especially the geology and morphology of the coastal areas. Artificial constructions, the modification made on the coast will disturb the equilibrium. Wind and sudden changes in wind direction also causes coastal erosion. Sometimes biological activities like root penetration and burrowing of sediments by organisms may weaken the compactness of the beach profile. The sands of the beaches are easily moved. Coastal and nearshore processes tend to mix, sort and transport the sediments. The geology of the beach forms is a major factor for erosion. If the lithology contains mainly limestone cliffs, then they may suffer by dissolution in water. As a result of wave action, a notch is cut at the foot of these cliffs. There will be an undermining action which will finally destroy beach forms. The shoreline is a dynamic system where stability is maintained despite the continuous movement of waves, tides, winds and sediments. High energy waves are able to transport larger amount of sediments. Although wave erosion is the more significant, the rates of movements are highly variable. Erosion rates vary depending on variety of factors including the weather and physical setting of the shore. Weather can also influence the size and frequency of waves striking the shoreline. The physical setting of the shore, that is, shore orientation, presence or absence of beach or man-made structures and the geology of the shore also contribute to erosion variability. Coastal erosion hazard degrees. The coastal erosion hazard degrees varies depending upon the average erosion rate, shape and spatial location of the coastal section, soil and lithology of the coast and the angle of the coastal slope. High degree of coastal erosion hazard creates average rate of 3 to 8 meter per year erosion. Straight and slightly convex shape and spatial location of the coastal section it creates, and soil and rock building up the coast is sand, and angle of coastal slope is about 2%. The moderate degree of coastal erosion hazard creates on an average about 3 meter per year erosion, and embayment shape and spatial location of the coastal erosion, and it also creates soil and rock building up the coast is sand, and average fairly steep angle of coastal slope. Coastal erosion hazard low in degrees, on an average it creates less than 1 meter per year erosion and embayment shape and spatial location of the coastal section, and it also creates sand and bedrock, soil and rock building up the coast and gentle angle of the coastal slope. High erosion disposition hazard creates average less than 3 to 8 meter per year. Shape and spatial location of the coastal section is near the river mouth, and sand is the soil and rock building up the coast, and less than 2% of angle of the coastal slope. The major impacts of coastal erosion are changing landscapes and beach morphology, frequent distribution of marine habitat, unstable basement for the growth of seaweeds and marine organism, turbulence causing disappearance of some marine life, forceful killing of some microbial life due to severe impact of waves, insecurity for settlement along coast, requirement of continuous dredging in seaports and harbors, impact over roads and other structures, threat to permanent infrastructures including real estate activities. Major impact of coastal erosion also includes loss of materials, submergence of coasts and their biota. It is very essential to protect the beaches on a long-term basis. The coastal protective measures are construction of sea walls, groins, jetties and other defense structures, fencing by vegetation, beach nourishment, breakwaters. Groins are linear structure constructed perpendicular to the shore. They are placed in groups. Each groin will trap some amount of sand that is moving in the littoral transport system. A groin field will lead to the development of a wider and more protected beach. The long-shore drift may be controlled by groins built normal to the shore, which can hinder the sediment movement. A beach builds up at the groin. Jetties are constructed on open sea coasts. A jetty is a structure extending into a body of water designed to prevent shoaling of a channel by littoral material and to direct and confine the stream or tidal flow. When built at mouths of river or tidal inlets, jetties are designed to help deepen and stabilize a channel. Revetment are put facing the sea, generally made of stone and placed on a bank or bluff to protect the slope or embankment against erosion by wave action or currents. Seawall is a coastal engineering structure separating land and water areas, primarily designed to prevent erosion and other damage due to wave action. Coastal defense construction features generally fall into two categories, namely hard defenses and soft defenses. Hard defenses are static shoreline structures such as those constructed using timber, steel, concrete, asphalt and rubber. These involve linear structures such as seawall, revetment and breastwork. Soft defenses are mobile or responsive defense measures which seek to work with nature rather than control it. Such structures may consist of sand or shingle beaches and dune banks, which may be natural or constructed. These can also include soft solutions of beach nourishment, cliff or dune stabilization materials. Vegetation plays an important role in controlling erosion. Vegetation helps to stabilize and preserve the shoreline. Although plants alone cannot protect the shoreline from wave attack or groundwater seepage, they help prevent soil runoff and wind erosion. Establishing vegetation is much cheaper than structural methods of erosion control, and the new marsh provides habitat, food and nutrients for organisms in the surrounding estuarine waters. Breakwaters are designed to intercept the action of waves. They block the natural littoral transport of beach sediment. Jetties are constructed often along the mouth of rivers. They are designed to stabilize the channels and prevent disposition of sediment in the channel. They also tend to beach sediments. They should be carefully planned and placed. The placement and construction of an offshore breakwater, which combined with the planted marsh can provide long-lasting protection at a relatively low cost, are described. A thorough understanding of coastal hazards will improve the estimates of total societal costs of coastal hazards, support engineering to minimize potential losses, and promote the public policy required to guide further coastal management. A critical additional goal is to increase efforts to educate the public and politicians with relevant and timely information about these issues. Continuous monitoring of the coastal regions are needed to protect them from these hazards.